In this video, I'll be solving this Math 31B Final Exam Study Guide. This is given by one of the instructors at UCLA. So let's begin. We are asked to determine the partial fraction decomposition of this function, okay? And conveniently, they already give it to us as factors over here. There's one linear factor here, and there's one quadratic factor over here. So we can write this as a over x plus 1. This is the form for a linear factor. And for a quadratic factor, it's bx plus c over x squared plus x plus 1. Notice that this was not factorable, so I didn't even have to do anything for that. Okay, so I directly went to here, bx plus c over x squared plus x plus 1. Okay, so this is equal to the original guy. So let me even write it one more time over here. Okay. Sorry, I'm going to change my stuff a little bit. Give me 1 second. Okay. Now I'm more comfortable. Okay. So this is the partial fraction decomposition. We're going to multiply both sides by this denominator. So on the left-hand side, we get minus 2x squared plus 1. On the right-hand side, what do we get? Well, the x plus 1s would cancel. We're left with the quadratic term. And then over here, we have bx plus c times x plus 1 still. Okay, I just multiplied both sides of this equation by this denominator. Okay, if you've seen my other videos, there's multiple ways you can do this. You can plug in values of x to get your systems of equations, or we can expand this whole guy out and match coefficients. So usually when there's a quadratic factor, it's usually faster, at least for me, to expand everything out. So let me do that. So minus 2x squared plus 1. The left-hand side, we don't touch. Distribute a to every term here, ax squared plus ax plus a. We're going to FOIL this out over here. This is bx squared plus b plus cx plus c. Okay, we're going to combine like terms now. So left-hand side, once again, we don't touch. We're going to combine all the x squared terms. So it'll be x squared times a plus b. Okay, so we took care of this, and we took care of this. So usually what I do is I just put a dot right under it to signal that I already took care of it. Let's get the x terms, so ax and c, so it'll be plus x times a plus c. Okay, and we have A, B, and C. Okay, so actually this should be here. This should be a BX because I forgot to distribute that. So this should be A plus, this should be A plus B plus C over here. So I took care of that also. And this is A plus C is this constant term over here. Okay. So I took care of all the terms. So we're going to match coefficients now. In front of the x squared is a negative 2. So we know that a plus b has to equal to negative 2. Over here, there's no x term over here. So we know a plus b plus c has to equal to 0 because there's no x term, so 0x. And finally, a plus c has to equal to 1. Okay, so here, I'm going to even write it like this. We have the systems of equations. So we have to solve this system of equations. Okay, let's call this equation 1, equation 2, equation 3. Okay, I'm just writing these numbers so that I can explain to you what I'm going to do. Okay, so we know a plus b is negative 2, so we're going to plug in equation 1 into equation 2. What happens when we do that? As I just said, we know a plus b is negative 2, so this we can replace as negative 2 plus c is equal to 0. So we know that c is equal to 2. Okay? We know c is 2, so we can find a from equation 3. So we're going to plug in c equals 2 into equation 3. So we have a plus c is 1. And I just said c was 2, so let me just write that. A plus 2 is 1, which means A is negative 1. All right, and now that we know A, we can plug it into equation 1. So we plug in A is negative 1 into equation 1. So it'll be negative 1 plus B is negative 2, which means that B is also negative 1. Okay, we have our A, B, and C. We can plug into our partial fraction decomposition. So I'm going to do it up here. Okay, so A was negative 1. Okay, B was also negative 1, so minus x. And then C was 2, so minus x plus 2 over x squared plus x plus 1. And that's our answer. Okay, that's how we do this partial fraction decomposition. Let's move on. Use the integral test to determine the convergence or divergence of this series. Okay, and they even tell you step by step how to do it. How nice of them. Okay, you even have to remember that to use the integral test, you have to show that it's positive and decreasing. They give it to you, so that's really nice of them, actually. Okay, so let's do part A. Let f of x be this function, which is from here. Instead of the sequence, we make it a function. On 3 to infinity, show that f of x is positive and strictly decreasing on 3 to infinity. Okay, so let's do part A first. How do we show that it's positive? Well, I know that ln x, this is greater than 0 for x is greater than 1. We know how the ln looks. I can even sketch it real quick. It looks like this. Something like that. And this point here is 1, where it crosses the x-axis. So we know ln x is greater than 0 for x is greater than 1. And we know that x to the 3/2 is greater than 0 for x is greater than 0. Therefore, f is greater than 0 for x is greater than or equal to 3. Okay? Technically, we're only interested when it's starting from 3. But I showed that log is positive when x is greater than 1. And this power function, technically, is square root of x cubed, is positive for x greater than 0. So, of course, f has to be positive when x is greater than 3 then. Greater than or equal to 3. Easy. Okay. Now, how do we show it's strictly decreasing? We can take the derivatives, okay? So let me draw a dotted line over here to show that I'm going to do it over here. Okay, we're going to differentiate this. So f prime, we can use, what do we want to do? Let's do the quotient rule. So bottom, the top derivative of ln x is just 1 over x minus top, d bottom, what's the derivative of x to the 3/2? That is 3 over 2 x to the half over bottom squared. Okay, so f prime is equal to, well, here we can simplify x to the 3/2 divided by x. We subtract 3 over 2 minus 1. We can subtract the exponents. So it'll be x to the half, okay, minus 3 over 2 ln x times x to the half over the bottom we can simplify as x cubed, properties of exponents. Okay, and finally, let me just factor out the x to the half. So in the inside, we have 1 minus 3 over 2 ln x over x cubed on the bottom. Okay, so let's go step by step. We know that x to the half is greater than 0 for x is, let's just use the 3 as the starting point. That should be clear because square root of 3 is positive, okay? And then we know how square root x looks. It looks very similar to this actually, but it should stop at 0 and then, start at 0 and then go up like that. Okay, we know x cubed is positive for x is greater than 3. That's easy. Now the remaining portion is this guy, 1 minus 3 over 2 ln x. This is less than 0 for x is greater than or equal to 3. Okay, and what did they even give us this hint over here that ln 3 is 1.11? Well, when we plug in 3 here, then we get 1 minus, let's round this down to 1. 1 minus 3 over 2, which is negative 0.5, which is less than 0. Okay, and then as x gets bigger, the log gets bigger, so it will become more and more negative. So therefore, f prime is less than 0 for x is greater than or equal to 3. Okay, so I showed that this is positive and decreasing. Integration by parts to show this guy, so they even give you the answer already. How nice of them again. This is the easiest types of problems, honestly, because they give you the answers. Okay, so you'll know that you did it right. Okay, so B, integration by parts. So how do we choose a U? How do we choose a dv? Well, we know that, or you should know that to take the integral of ln, you need integration by parts. So let's let U be ln x. Du is 1 over x dx. dv would be, we can say x to the negative 3 halves, because this is x to the 3 halves on the bottom. Same thing as x to the negative 3 halves. V would be what? It would be x to the negative half divided by negative half, which is negative 2 x to the negative half. Okay, so I'm just setting up my integration by parts. Now we do use the formula uv minus v du. So uv would be minus 2 ln x times x to the negative half. So let me say I, that's the integral. I is equal to this guy, and then minus v du, so this is minus here, so it'll be plus 2 integral x to the negative half over x dx. Okay, so let's simplify. This we can leave alone, so let me even just move that guy outside first, or as the first term, okay? Plus 2 integral, how does this simplify? As we did up, where did I do it? Up here, we can subtract the powers, because we're dividing. So it would be x to the negative 3 halves dx. Okay, and this we can integrate. What is that? So the first term remains the same. And actually, didn't we just find this integral? It's right over here. Okay, so it would be times minus 2 x to the minus half, okay, plus c. We can even simplify a little bit. Plus c, okay? If we want to make it look exactly like this, we can factor out the x to the negative half. So we would be left with minus 2x, sorry, minus 2 ln x minus 4 on the inside. And then we can move this negative exponent down, so it'll be minus 2 ln x minus 4 over square root x. And this is exactly what they have right here, except I just have the minus 2 ln x first, right? So easiest type of problems when you just have to verify. Okay, part C. Evaluate the improper integral by definition. You may use part B. Okay, so let's just write the proper limit definition of this improper integral. So it'll be limit as t approaches infinity, integral 3 to t of ln x over x to the 3 half dx. Whoops, did I get cut off? This is what I'm writing. This is the limit definition. We already found the antiderivative. It's right here. So let's use it. It would be limit t approaches infinity of, put some big parentheses. This is the antiderivative, so minus 2 ln x minus 4 over square root x. We evaluate this guy from 3 to t. Okay, so what would we get? We get limit t approaches infinity of minus 2 ln t minus 4 over square root t minus parentheses minus 2 ln 3 minus 4 over square root 3. Okay, this is just a constant, so we just have to worry about this limit over here. Okay, I'm running out of room, but let me do it in... Let me do it over here in purple, okay? So we want limit t approaches infinity of minus 2 ln t minus 4 over square root t. If we plug in infinity right away, we get infinity over infinity. So that's indeterminate. We can use L'Hopital's rule. So we're going to differentiate the top. Let me write the limit notation. We differentiate the top, we get minus 2 over t. Okay, and derivative 4 is just 0. And then the bottom, we get 1 over 2 root t. Okay, so we simplify. Limit t approaches infinity of, we can bring this to the top, so it'll be minus 2 times 2 root t over t, which is limit as t approaches infinity of, this is minus 4, this is divide by square root t, okay, which is 0. Limit as t approaches infinity, the bottom gets bigger, so we approach 0. Okay, so we found the limit of this portion is 0. This is just a constant, so we still are left with that. So we have 2 ln 3 plus 4 over root 3. I distribute this minus sign to both terms there. Okay, so this is the answer for part C. Okay, and finally part D, we're just going to use the integral test to determine if this converges or not. Well, the integral converged, so by the integral test, it also converges.